Let's answer day 2's homework, just so that you can go over it. I'm going to go over this pretty quick. Potassium iodide, K1 plus, I1 minus, Ki. I'm just going to read out the ending. Aluminum chloride, AlCl3. Lithium nitride, Li3N. Barium hydride, BaH2. Sodium chloride, NaCl. Silver bromide, AgBr. Magnesium chloride, MgCl2. Zinc chloride, ZnCl2. If you don't like listening to my voice, just pause it and correct on your own. Next one. MgO, magnesium oxide. NaBr, sodium bromide. Al2O3, aluminum oxide. CaO, calcium oxide. ZnO, zinc oxide. Ag2S, silver sulfide. CaF2, calcium fluoride. CaH2, calcium hydride. So those are all simple ionic compounds. You should be able to name them. You should be able to build the formula from the name, build the name from the formula. Molecular compounds. Nitrogen, N2. It's one of our diatomic guys. Argon, Ar. Sulfur dioxide, SO2. Carbon monoxide, CO. Ozone, that's one from the table that you should know. I believe it is from right here, from these common substances. Ozone right there, trioxygen, ozone. O3. Ethanol. Ethanol's on here, it's C2H5OH. C2H5OH. Naming, CCl4, carbon tetrachloride, nitrogen monoxide, nitrogen dioxide, sulfur trioxide, tetraphosphorus decoxide, tetraphosphorus hexaoxide. Pretty quick, pretty easy. Just put in the work. Now let's balance these guys. First one, we've got a hydrocarbon and oxygen giving us carbon dioxide and water. So let's take a look at our C's. 3, 1. So I want to put a 3 in here. Now you should do these in pencil if you need to erase and work them over. H's, 8, 2. So we need a 4 in here. O's. So C's and H's are good. O's, 6 and 4 is 10. So we need a 5 in here. This is 1. 1, 5, 3, 4. Propane and oxygen gives us carbon dioxide and water. Hydrocarbon plus oxygen, carbon dioxide, and water is a combustion reaction. Number 2, C8H18, O2, CO2, H2O. Balanced combustion reactions the same way, right? This one's also combustion. Not sure what the name of this guy is. So we start off with our C's. We're going to need 8 of these guys. H's, we're going to need 9 of these guys. But now we're going to get into a problem, right? Because we have 16 and 9. 16 and 9 is 25. 25 means we could multiply this by 12.5 to get to 25. So that's balanced. 1, 12 and a half, 8, and 9. But we can't have decimal numbers, so we just double everything. 2, 25, 16, 18. It's a combustion reaction. Next one, we've got Fe with the Cl. We've got Na with the OH. Then the Na switches with the Fe. See, the Fe is now with the OH and the Na is with the Cl. What kind is that? So let's balance things out. So Fe, 1 Fe, 1 Fe. Fe's are good. Cl, 3 Cls, 1 Cl. So we need 3 of these guys. Now our Fe's and Cl's are good. Now let's get to Na's. 1 Na, 3 Nas. So we're going to need 3 of these guys. Now we treat OHs as a single entity because it's a hydroxide. So we don't talk about the O's and the H's. We talk about our OHs. So now we have 3 OHs here and 3 OHs here. This is good. 1, 3, 1, 3. Now we've got this Fe and this Na. The Fe was with the Cl3, but now it's with the OH. The Na was with the OH, but now it's with the Cl3. This is a double displacement. Display. All right, so now we've got P and oxygen. Phosphorus and oxygen gives P2O5. Okay, so if we want to balance the P's, well, we just double this one, right? We put a 2 in here. 2 P's, but now we need to do the O's. We got 2 O's here and 5 O's here. 2 O's and 5 O's, we need to get that to 10. So we're actually going to need a 2 in here to get that to 10. 5 in here to get that to 10. And then we're going to need a 4 in here. 4, 5, 2. Now we have two things coming together to form one thing. What do we call it when two things come together to form one thing? Synthesis. All right, so now we've got Na plus H2O gives us NaOH and H2. Now, whenever you see something with OHs and H's and with OHs on one side, we've got H2Os over here. We change our H2O to a HOH. You can put a brackets around that OH to indicate that it's kind of separate. And we deal with this hydrogen separate than this OH. All right, so NAs are balanced. Good. H's, we have one H over here, we have two H's over here, so we need a 2 in front of this. We do, because there's only one H. This OH gets treated separately. It's its own ion. So we need a 2 here. But now we've got two OHs and one OH, so we need a 2 here. Now we've got two NAs, so we need a 2 here. And now it's balanced. Two NAs, two NAs, two H's, two H's, two OHs, two OHs. Now what type is this? Well, this sodium and this hydrogen out front switch spots. So we've got a lone guy switching spots with a guy in a couple to get a new couple and a new lone guy. So this is single replacement or single displacement. Last one. Ag2O gives us Ag and O2. Two Ags here, so we put two Ags here. One O, two O, so we need a 2 here. But then this makes this guy 4. And this is a 1, and it's balanced. 4 Ags, 2 O's, 2 O's. We've got one thing here being broken apart into more than one thing, so that's a decomposition. All right, last thing, Lewis dot diagrams for arsenic trichloride. So let's find ourselves arsenic, and let's see what it's got on it. Arsenic. So, arsenic is As. It has 33 electrons. So you have to figure out how many are in the valence shell. Well, 2 electrons are in the first shell, 8 in the second shell. In the third shell, there are 18. So here we've got a total of 28 electrons already, 28 electrons in the first 3 shells. So in the last shell, in the valence shell, there's only 5 electrons left. Okay, so arsenic. Arsenic, which is As, has 5 electrons in the valence shell. Now, we can determine that by looking at it where it is on the periodic table. It's in this one, 5A, 5 valence shells, 5 electrons in its valence shell. These guys right here. Chlorine has 7 electrons in its valence shell. And we have 3 chlorines. I should give them a different color. So arsenic needs 3 more electrons in its valence shell. Where is it going to get those 3 electrons from? Well, it's going to share one from chlorine from each chlorine. Each chlorine needs 1 more electron in its valence shell, so it's going to share 1 from arsenic. So we're going to put our arsenic in the middle. Arsenic, and it's going to have 1, 2, 3, 4, 5 electrons around it. Then we're going to fill in a chlorine right here. And this chlorine is going to have 1, 2, 3, 4, 5, 6, 7 of its own electrons. Notice that there is a bonding pair right here, and there's 3 lone pairs. Likewise, there's going to be a chlorine down here. It's going to share 1 of its electrons with arsenic while borrowing 1 electron from arsenic. And then the rest of its 7 electrons like this. So a bonding pair, lone pairs. Our third chlorine is going to go here at the other spot. It's going to share an electron with arsenic. Meanwhile, it borrows an electron from arsenic. 1, 2, 3, 4, 5, 6. Done. There is arsenic trichloride. Last one, H2S. So hydrogen has 1 electron in its shell, valence shell, but hydrogen only wants 2. Hydrogen only wants 2 electrons in its valence shell. To fill up the first valence shell only takes 2 electrons. So hydrogen and helium both only want 2 electrons in their first valence shell. Then we've got our sulfur. Sulfur is right here. It has 6 electrons in its valence shell. It's 16. 2 and 8. 2 in the first shell, 8 in the second shell. That's 10. There's 6 left in the last valence shell. So sulfur has 6 electrons in its valence shell. So how are we going to fill up the sulfur? Well, it needs to borrow 2 more electrons. It's going to borrow 1 from this hydrogen and 1 from this hydrogen. This hydrogen wants 2 electrons in its valence shell. Where is it going to get that electron from? Well, the sulfur, of course. So let's put the sulfur in the middle. And we'll make it bond on the sides. 1, 2, 3, 4, 5, 6. Then we've got 1 hydrogen over here bringing its lone electron to right there. We've got another hydrogen on this side bringing its lone electron. So now the sulfur has 2, 4, 6, 8 electrons in its valence shell. This hydrogen has 2 electrons in its valence shell, and this hydrogen has 2 electrons in its valence shell. Those are the Lewis dot diagrams. All right, so I hope this was helpful for you for this homework. I hope you did it. You got it all right. And thank you for watching.